Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these hard tag problems, and yes, it's obviously an hard problems. There is a very strong intuitions basically hidden behind the problems, and if you can get it, then only you are going to basically come with the most optimal time and space optimized solutions for this. But in an interview perspective, I definitely need, like, if anyone is need to solve within an interview boundary, then they need a very like good amounts of intuition practice on intuitions building problems. Yeah, so first let's try to understand the problem statement. So they are basically looking for find the maximum sum of node values. So for this, what they have given to us, there exists an undirected tree with n nodes numbered from 0 to n minus 1, and you are given a zero indexed 2D integer array ages of length n minus 1, where ages I is ui vy, indicates there is an age between nodes ui and vi in the tree. You are also given a positive integers k and a zero indexed array of non-negative integers nums of length n, where nums I represents the value of the node numbered I, right? So they basically given a tree, or you can say it's a graph altogether. They have basically given the ages of the tree or graph, and they are also given you a non-negative integers nums of length n, where nums of I represents the value of the node numbered at I. Now allies wants the sum of the values of the tree nodes to be maximum, for which allies can perform the following operations any number of times, including 0 on the tree. Choose any edge u and v, connecting the nodes u and v, and update their values as follows. So what we can do, what allies are allowed to do, he can select an edge from the tree and XOR with the k factors of the node, XOR with the k factors of the node value, right? He can do that. So nums of u then becomes nums of u or u of XOR of k. Nums of v is going to become nums of v XOR k. And like this way, return the maximum possible sum of the values allies can achieve by performing the operations any number of times. He is allowed to perform these operations any number of times. Now in this example test case, you can see, so that is the graph, or more specifically tree they have given. So anything's fine. You can consider it as a tree or graph altogether. There is no issue on that. So here you can see that there is an age from 0 to 1 and there is an age from 0 to 2. And what is the values it is holding? It's holding values of 1 to 1. So the value on this node is 1. The values of 1th node is 2, and the values of 2th node is 1. So if we can go to our favorite one node to do the explanations for this. So what they have basically given to us, they have basically given a, now it started, oh shit yaar. Yeah, so that is the graph or tree they have given, and they have put what is the values they have given to us. They have given, I guess, 1 to 1. Yes, 1 to 1. So the value, sorry, so the value of the, what is happening there? Yes, so the values of this node, oh shit, I think one node has crashed. So basically the values of this node is 1, and the values of this node is basically 2, and the values of this node is 1. Let me try what happens to this. Can it allow us to write it? Yes, I guess yes. So basically they have given a graph to us. Now yeah, there is a huge problem to write it like this. So that is the graph they have given to us, and the values it is holding. This node is holding values of 1. So that is 1 to 1. This node holding 2, and this node holding values of 1 again. So now the k factor they have given to us are 3, I guess. Let me check it. Yes, the k factor they have given us 3. So what we can do, we can XOR them with 3. But which node we have to do the XOR? Which node we have to do the XOR? We can do the XOR of 3 to this node, because we are allowed to select any two edges. Like we are allowed to choose an edge. So for an edge, how many nodes? There are 2 nodes. So we have chosen this particular edge which is holding this node and this node, and we can this XOR with 3, and it becomes 2, and this is also becomes 2. Now everyone is 2 to 2, and when we do XOR with 3 of this node, then it becomes 1, I guess, because 1 1 1 0. So 1 1 is going to be 0. So I guess you guys know XOR. So for the truth table of XOR is 1 XOR 1 XOR 1 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, and 0 XOR 0 is 0. So basically x XOR x is going to be 0. So that is the truth. Like if both the numbers are set bit to a particular positions, and that is the truth tables. That is the XOR truth tables we have it, and that is a special factor. That is a speciality of XOR. Speciality of XOR. So if you can do XOR of two same numbers, it becomes 0. It becomes 0. The output is 0. Right? With these couple of things, I think we should be able to solve this particular problem. So here you can see where we saw to our one node, it's XORed between these two node. Sorry, these two node 0 and 2. Choose the 0 and 2, and nums of 0 and nums of 2 are 1 XOR 3, that is of 2, and the first one is again 1 XOR 3 again, right? Because we have 1 to 1, and it becomes 2 to 2, and the total sum is 2 to 2 plus 2 is 6. So that is the maximum possible sums you can achieve. Similarly, on this example test case, you can see that 2, 3, and 7 is given to us, and you can do the XOR of 2 XOR 7s, it becomes 5, and 1 XOR 7s, it also, sorry, 2 XOR 7s is becomes 5, and 3 XOR 7 it becomes 4, and that is the maximum. So 2, 3 has converted to 5, 4, 5, 4. And 5 plus 4 is 9. That is the maximum sum you can achieve. And for this example, you can try on your own, and you don't need to try. You just basically build intuitions for now for sure, because on this example you can try, but you don't need to try. The output what they have given, that is the maximum you can achieve. Now we can go to our favorite one node to basically understand what actually the intuitions. The intuitions is actually on different level of difficulty. So that's the reason I'm focusing on intuition, because once you get the intuitions, like solving it like this kind of game. So the first things is, of every graph problem, that is the general steps you have to follow. Try to write some arbitrary graph, right? And second one is try the operations on it in pen paper. So that is a must have. That is the must have things to basically understand the intuitions behind that particular problem. So you can so for that I can follow the rules what they have given to us. So let's suppose that is an arbitrary graph. We have it. So tree and graph are like, let's consider it's same only. So now the key factor. If we have num, so the key factor. What is the key factor for this particular problems? The key factor is first one, if I have nums with it, if I do the XOR with, let's suppose, some number x, so nums either can go down. Second, if I do nums of XOR with x, it can either to go up, right? Agree or not? So that is the key factor. That is the key factor for this particular problem. So when we are doing that number with a constant XOR to that any number, the numbers can either go down, or either can go up. Why so? So let's suppose my number has set bits kind of this, right? So that is the bit set to that particular given num. So let's suppose that is my num, and let's suppose the XOR, that is the x we are considering, let's suppose has set bits to exactly the same positions, same positions. Now if you can do it, this becomes turned down, this is already turned down, this becomes turned down, so this is going to be all zero. So the entire numbers is going to be 0 only. So on this example we saw when we did XOR, it becomes entirely turned down. But again, if I consider the same test, same example, so that is 1 0 1 0 1 1 0, that is my nums. And now if the XORs is basically have the bits to the alternate positions of my parent number, then this becomes 1. This number is first turned to 1 by doing the XOR. This is already 1. This one is turned to be 1. This one is already 1. This one is 1, and this is also again a turn to be 1. So all bits we are able to set. So that is maximized. Here. But here it's completely went down. So there are two possibilities. So when we are doing a XOR to a number, it can either go up or it can either go down, right? It can either go up or it can either go down. So, but what we are interested, what we have to search for, we have to do it's maximized. We are looking for. So are we bothering of these operations? No, that is useless for us. So we are looking for this operation 2. So I am basically looking for, we will perform the XOR of that particular nodes only. We are performing the XOR to that particular nodes only, where after doing the sort, the value can grow up, For other nodes, we are not going to do any operations. Okay. Shouvik, you are very good state to explain that. But now give me a strong intuitions how it is going to be work. So you can try to sort what is the nums value to that particular graph, what is the nums they have given to us, and you can try to do a sort. So there are two possibilities now. It can either grow up or it can either go down. So I am stating after doing the sort, Shouvik, this node, and let's suppose this node are increasing, these nodes are increasing, these three are increasing. But for other nodes, they are decreasing. So Shouvik, very careful. You can't do sorts for this node, and this node. Be careful. Don't perform any sort to that particular node. You can do to this, and this. Like this way, you can get your answer to be maximized. But okay. Then I am good, but not totally. Now I have these two nodes, which actually need to be zored with. So now I know. If I want to do a sort of these two, I am not allowed to do so because there is no edge. There is no edge between them. There is no direct edge between them. So I am trying. If I can populate these zorations via some path, because that is a graph, no? So what I am trying to do? I am basically trying to zor these two, right? But I don't have any direct edge. So how I can populate these zor factors via some path? So let's try. So let's suppose. So I am again taking an arbitrary graph. So let's suppose that is my graph, and I want to basically do the zor of these two, and there are multiple nodes among them. There are multiple paths. Let's suppose there is another path like this. Let's suppose there are another path like this. But I want to do zor of these two. But there is no direct path. If there is a direct path, then we are good. But there is no direct path. So I know I have to populate these zor factors via some node path. So let's try. So I am going to take this one and this one. So I have zored it. So here I have zored it with x. So it becomes increased because I have zored it with x. And this zor with this x zor, it becomes decreased. No. You don't allow to do decreased it. So for that reason, I am again greedily pick this and these two. And it is zored with x. And it is become first zor with x. And it becomes 2 zor. So now tell me what actually the principles we have already discussed. If the zor, if a particular zor we have done on twice of a number, then zor x is going to turn the bit to be 0. So this is going to be neutralized, and it becomes its previous form, its original form. It becomes to its original form. So the zor factors, what we are basically trying to avoid to these intermediate nodes, we are able to achieve. There is no zorations, but this has the effect exactly that we are looking for. Now this has a single effect again. So that again we are trying to neutralize. Again, populate this zor with these two. Now again you have zor this with zor x. Again this is going to turn down to be 0, and this has a single zor factor. Again zor these two. So these zor factors is now populate to, this is the first zor of x, and for this it is again going to turn down to neutralized to 0. Yes. So finally you can see I am able to achieve a single zorations. So double zorations means zor is neutralized. The number 2 becomes its original form. Single zors, is zorized. So this has zorized, and it becomes increasing, that I know exactly that we are looking for. This becomes zorized, and I know it's going to become increased. So see guys, I am able to populate my zor factors when there is no direct edge between them. I am able to populate the zor of x via some path. You can select. I think you guys definitely get the gist. So that is the most difficult path I have choose, but here also you can choose. So if you are coming to this, so it becomes first time zored with this, and again it becomes zored with this. So there are 2 zors and it becomes neutralized. Again similarly for this also, like this first zorized with this, second zorized with this, its factor gone. Then again it has a single zorized, and it becomes zorized with this factors also gone. So like this way you should able to in all the cases you should be able to populate your zor factor to from one node to another node, no matter there is a direct path between them or not. But we should be able to populate this XOR factor. So now I think the problem is now going to very simple, very simple. So if that is the graph is given to me, and if there are arbitrary some node where I basically, let's suppose this is the node and this is the node, which Zoraized increase the value, which Zoraized increase the value. So I know I am able to populate this Zoraized. I know I am able to populate the Zoraized. Yes, yes. And now there are two cases. If so, on this example test case, how many of them is going to increase the value after Zoraized? There are two. Yes. So now we have two cases. The first case is if the count is even. What count is even? For which after XOR value increase. So if their count is even. Second is if their count is odd. So for even, can you guys like stop the video and think on your own? If the count of nodes where after doing the Zoraized the value is going to be increased, if their count is even. So let's consider again a graph. You can consider again a graph, right? So let's suppose this node, and this node, and this node. So let's suppose the count is even where after doing the Zoraized the value is increased. So I know I can populate this XOR factor between in this and this, or this can go to this also. So I can select any two pairs, any one pair. So that is a pair, no? So I can make them to be increased without affecting the any intermediate node on the path, without affecting any intermediate node. So that is the path, no? So without affecting, because we will do the Zoraized of twice to that particular number, and then it becomes neutralized. That we already saw. So if we have even count, if we have even count, so that means we always have a pair. This basically pointing, it's always have a pair. So that means you can select either of the pairs, and you will make both them Zoraized, and both of them is going to be increased. But so that is a very simple case. So for this, what's the algo should be, on which after Zoraized it becomes increased, do them XOR with k, and for which it becomes decreased after XOR, take it only nums of I. So here it becomes nums of I XOR k. Where increase, take it as a nums of I XOR k, and where decrease, take it as a nums of I, and you should do the summations of these alls, and what is the answer you are going to get? You can return it. You can return that. Yes, this even is very simple. Agree or not? If we have even number of counts where after doing the Zoraized it becomes increased, so I can select them as a pair and populate the XOR factor via some path between the targeted nodes, between the targeted pair nodes. Yes, the problem is as simple as that. But now the challenge is, if we have a count of is odd. So now let's look into this. So let's suppose this and these three becomes increasing. Now actually the challenge. So now you know I can do pair of any two of them, and they are become increasing. And for them I will take it as it is, because their XORs becomes more down it. So for this node and this node I can take it as it is. But there is a node which is also claiming if you do me with XOR, then I am also increasing. Okay, you are also increasing, no? But I don't have your supported pairs, because on even I have a supported pairs where someone also is waiting to become Zoraized, and it is also going to become increasing. But for you, for odd, you don't have a pair for which you can do Zoraized, and you can also increase him, and you can also increase yourself. But on odd, you don't have anyone's. Okay, so I don't have anyone, no? So what then I can do? So first ones, either you can become like as it is without Zoraized versions. That is the first options. Nothing has done to this number. The second option, that is the intuitive. Okay, if you can Zoraized with me, I am basically giving you some contributions. Okay. So tell me what actually extra contributions you are giving to me when I am going to Zord it. So you are stating me you are going to increase, but what factors you are going to become increase? It's nothing but my nums of I if this particular node, this particular orphan nodes, no, this particular orphan nodes is crying that, hey man, please zord me, I am giving you very high value to your answer if you zord me, but I don't have any supported pair, no, so that I am not going to increase him also. Someone is going to be decreased on that case from your pair, because others are satisfied without zord versions, others are satisfied without. So but please try to zord me, no. I am basically committing you that I am increasing your answer in a very high node, but other node is also going to be making me stuck. Hey man, if you zord me, no, I am going to decrease your answer for sure. But this node is also pushing me to zord me. I will increase your answer to a heavy amount. So now I think I have to play a smart game. So I am asking, hey orphan, what actually you can contribute? What you are stating? No, if I sort it out with you, then you are going to increase my answer to a very high node. So what is that node? What is that high node? So he is stating, sort it with me and minus it to myself. What is my original version? So that is my original version. So that much contribution. So I can store it in a contributions to a contributions variables. No, contributions variables. So here the orphan node is contributing that much to my answer. Now, okay. So you are doing a lot of contribution to my answer. After doing that operations, I am going to agree, okay man, you are going to contribute a lot to my answer. So I then have to compromise to someone who actually basically in its original versions is already high, but when I'm doing to zord, it's become decreased. So I have to find if there is anyone who is basically his contributions, let's suppose contributions 1. Oh shit, yaar. This is annoying, no? So now it will take some time to go to that. Yes. So now I am stored it as a contribution 1. So now I am wondering if without zord anyone, they are basically forcing me, if you zord me, I will decrease your answer. So I am basically looking for, okay, then on your fresh versions, what actually the contributions you are doing to my answer? How I can ask them? So they are basically contributing as a nums of, let's suppose, j. And if I can zord them, then they becomes nums of j zord k, So that is the delta in contributions. So here it is basically giving me nums of zord of k minus nums of I. That is the extra contributions it is giving. And this nums of j, which actually happy to ask me, basically add me to my own versions. If you zord me, I will decrease your answer for sure. So I am asking what decrease you will do. So I am storing it. So its impact, or more specifically I have to say its impact. Its impact is, let's suppose, impact 1. Or I can don't want to not need it. So it is going to impact my answer to be that much amount. And and the good one, which the orphan nodes, which basically stating, if you zord me out, then I can increase your answer to be that much contributions amount, right? So I now have to choose. I have two options. Either I can zord it to get its more contributions to my answer, or I can zord a number which its original versions is good. I am going to zord it and take its negative impact. So when I am going to do this, if my contributions, that is the orphan nodes contributions, extra contributions to my answer is more than the impact, the negative impact, when I am doing to zord with a fresh number, which is basically stating me my original versions I am good, with zord versions I am bad. If the contributions of the orphan nodes is more than the impacting node, then I am going to take the risk. I am very eagerly can take the risk. So I am going with this. So basically, if I am trying to generalize now these two, the first one is this, that is the impact one, that is the first, and that is the second one. So I know if I want to get the orphan nodes to my answer, I have to sacrifice someone. So I am basically looking for what is the minimum sacrifice, or what is the minimum contributions amount I have to sacrifice. So I can take care of min contribute variables. So that basically storing min contributor, which is contributing very less to my answer, and I have initialized to be very high value, int max, let's suppose, or sys.max size, anything as per your language, and I am basically looking for who is the actual minimum contributor, because I am going to hit it. I am going to take a risk for them, and I am final answer. I am going to take out that much to my answer, so that I basically want my answer should be maximized. My answer should be maximized. I will zor to everyone who are basically stating me I will increase your answer, and I am not to zor to all of them who are basically stating if you zor me I will decrease. So I am following the exact even algo. For even count, which algo we have followed? We have followed exact same algo, but we need a mean contributor to be identified. So that what we can do for mean contributor, we are going to take a hit. We are going to take a hit for them. Either it is increasing to my answer, then I am not going interested to your increase. I am taking it as it is. And if you are decreasing to my answer, then let's decrease. I am not going to bother about that, because I have found a contributor which is increasing to my answer, an orphan which is increasing to my answer a very high amount. So my mean contributor on that case, if I am generalize these two, so that is the first, that is the second, should be mean of them. It should be mean of them who is actually minimum contributing or impacting to my answer. That is the culprit. I can take hit of them. So my mean contributor should be minimum of, for if it is an increasing, my mean contributor should be as it is, minimum of my mean contributor, and if it is an increasing, so let's suppose nums of I zor k is going to greater than my nums of I, right? So with zor it becomes increase my answer, so its contributions becomes how much? Nums of I zor k minus nums of I. That is the first case. That is the contributions of this orphan nodes, right? That is the contributions to that orphan node. And we have an else block where it is basically stating if you can increase my zor versions, I will decrease your answer, I will impact your answer. So tell me what impact you can put. So that is also mean of my contributor, and nums of I, it is putting an impact of nums of I minus nums of I zor k, nums of I zor k. Yes, so I need that much hit to my answer for sure to get my answer to be maximized. So whatever the answer we are calculating in the even count, we are basically doing the zor when it is increasing, we are not doing the zor when it is decreasing. And finally, what is the if it is an odd, then I am minus what is the mean contributor contributions, because I am going to allow a hit for him. I am going to allow a hit for him. That is the mean contributor. I am going to sacrifice you. You can go off to my answer, and then also my answer is maximized. Yes, guys. So that is the beauty. That is the intuitions is actually hidden to this particular problem. Now we can quickly discuss the code iterations. So the code is very simple. I have to say, I need an increasing elements count. So that is increasing elements count. I need an answer, and I need a minimum contributor for sure, and I am increasing them accordingly. And I need an n to be len of nums, and I have for I in range n, I am doing iterating to the nums, and see, I am doing the zor of it, zor of nums of I zor k, and if it is an increasing after zor, it becomes more than its original version. So I have found one increasing elements which after zor it's become increasing. So I have increased my increasing elements count, and I have take its zor versions. So its zor versions is stored in zor elements, and also we have calculate to our minimum contributor here. So on this case, its minimum, is it the minimum contributor? Okay, let me check. Its contribution is nothing but zor elements minus nums of I, because zor elements is the higher versions of it minus its original version. So like this way I am able to check what is the contributions it is doing, and I am minimizing with my already stored minimum contributor. And on else block I am adding to my answer to its fresh versions, because if I am doing to zor it is going to become decreased. And here also I have calculating my minimum contributor, same mean of my minimum contributor and its original versions minus zor elements, because here I know its original versions is increasing, with zor it's become decreasing. And now if my increasing elements count is an odd, so that means we have to go for the second approach. So I have to omit the minimum contributor contributions to my answer, and I know which variables is storing it. It's stored in minimum contributor contributions. So this variable is storing the minimum contributor contributions to my answer, and I am going to take a hit on this. So I have take the hit by omitting to this from my answer, and I am returning. And if that is not so, if all are even, then I am fresh. What is the answers we have generated? We are very happy to return that only. Yes, guys, the problem is as simple on implementation perspective. It is as simple as that. So the main game is the pen paper work. How good you are basically identify the intuitions behind this particular array. See, guys, I don't use altogether the ages variables. You can see I have used there is no use of this ages variables. This graph factor is just for your whiteboarding, just for your pen paper work. If you are find out the most optimal algo, that is it. That is you can operate to your nums array only. It is basically the ages things, graph things is basically giving you to make the question more complicated, but you have to find the root of these particular problems like simple pen and paper work. Yes, and you can see I have submitted it, and it is kind of the most, it is bound to be the most optimal solutions. And I think I don't have, no, I have reached the daily limits. So yes guys, now we can quickly discuss the time complexity. I think there is nothing to as such discuss on the time complexity, but tell me guys, we are only iterating a single for loop that is going to take a only big O of n for sure. The space perspective. Do you guys see we are using any extra space? Nope, nope, nope. All are variables, all are variables. So on space perspective, it is a constant space submissions for sure. It is a big of one. And that is bound to be, you can see our memory is 91% faster and our runtime is kind of like 80% faster than all the submissions over there. So that is bound to be the most optimal time and space complexity you can achieve for this particular problem. And if you guys are able to understand till this point, I know understanding these problems, also explaining the intuitions behind this particular algo is on like kind of on different universe altogether. The difficulty of kind of on different universe altogether. And if I am able to do so, so please do subscribe to the channel, which you guys are already doing, and please share the videos to your friends who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye guys. Bye bye.